So today's video is on balancing equations. Balancing equations is something you should have learned before in 8th grade, but if you haven't seen it before or you want to see the new tips and tricks that I have to help you, that's what this video is all about. So why do we balance chemical equations? The simple answer is, in a chemical reaction, and you learned this already, mass is always conserved. So we balance equations to show that in a chemical reaction, no matter is created nor destroyed. If you think back to what we just did the other day where we were building and breaking down molecules, you remember that we had a chemical reaction in which we added sodium bicarbonate, NaHCO3, to hydrochloric acid. And what came out of it was we got carbon dioxide, water, and some salt. If you were to draw these molecules out, you can see that we didn't add any atoms, we didn't take away any atoms, but instead we just rearranged the atoms so it looked something like this. So if you count up both sides, you'll see that over here we have, one carbon atom, we have 3 oxygen atoms in the red, we have 1 sodium atom, we have 2 hydrogens, 1 there and 1 there, and we have 1 chlorine atom. On the other side of the equation, we have the exact same setup, right? We have our 1 carbon, which is right there. We have our 3 oxygens here, here, and here. We have our 2 hydrogens, which are both off the oxygen. And we have our sodium, and we have our chlorine. So once again, we didn't add any atoms, we didn't destroy any atoms. The equation is balanced. You also saw a more complicated example when we made the compound water. If you remember, when we made water, we started off with 1 molecule of oxygen gas, which is O2, and 1 molecule of hydrogen gas, which is H2. And we broke apart and put them back together, we were left with a molecule of water, H2O, and this extra atom of oxygen. Since this can't be by itself, we had to add another molecule of H2 to get this second molecule of oxygen. And what we were left with was 2 H2s and 2 H2Os, which we wrote as 2H2 plus O2 gives you 2H2O. So let's start with how I balance equations. So most of the time in this class, you're going to get an equation and it's not going to be balanced. Remember that if you want to balance an equation, the number of each type of atom on each side of the equation, so on both sides of the arrow, has to be equal. So the number of each type of atom in the reactants has to equal the number of each type of atom in the products. So the best way to do this is to make a chart. Now, it is really important when you make this chart, and you're going to want to do this in a different way, but it's really important when you make this chart that you actually do it in the same order on both sides, and I'll show you why in a second. So let's go atom by atom first. The first atom in the reactants is calcium. The next atom in the reactants is oxygen, then hydrogen, then potassium, and finally bromine. We're actually going to put them in the same order in the products. We'll go calcium, oxygen, hydrogen, potassium, and bromine. Then we have to count on each side. So in the reactants, we have no subscript on the calcium, so there's only 1 calcium. The oxygen is in parentheses, and there's a 2 outside, so there's 1 inside, and if there's 2 of them, it's 2 total. Same thing with the hydrogen, because remember there's 1 of each inside the parentheses, but there's 2 of them. And then potassium is 1, and bromine is 1. On the other side, calcium is still 1. Oxygen this time is 1, as is hydrogen. Potassium is still 1, and bromine is 2. So we've done our accounting, we've accounted correctly, and that's really one of the harder parts of all this, is getting your accounting correct. Then to go on, what you're going to want to do is you are going to want to find an easily multipliable relationship. So I do my checklist. I'm going to start in red here. Calcium is already done. Potassium is already done. But the rest are not. Oxygen has 2 in the reactants and 1 in the products. Same thing with hydrogen. And bromine is reversed, 2 in the products and 1 in the reactants. So we need to find an easily multipliable relationship. And it starts right here as I work my way down. There's a 2 and there's a 1. If I multiply 1 times 2, I can get to 2. So what I have to do is find where the 1 is, which is on this side, and I've got to find where the oxygen is. And the oxygen sits right here with K. So in order to double that, I can only add a coefficient. I cannot add subscripts. You can't change the subscripts. Remember, subscripts are determined by the ionic compounds in the formula. So you cannot add subscripts. You can only add coefficients. So I've got to put a coefficient in front of this whole thing. I'm going to put a 2. And then I've got to do my reaccounting. When I do this, I'm going to work left to right in the formula. K actually increases to 2. It's no good anymore. O increases to 2, and H increases to 2. So O and H are now set, and we've got an issue with K, and we've got an issue with Br. Once again, though, K in the reactants is 1, and Br in the reactants is 1. K in the products is 2, Br in the reactants is 2. This is an easily multipliable relationship. I've just got to multiply it by 2. So we'll start with K. We find where the K is. It's right there. I can put a coefficient of 2 in front of it. Remember, you cannot add subscripts. You can only add coefficients. And K, when I multiply it out, becomes a 2. Bromine becomes a 2. And suddenly, all these numbers are even. 1, 2, 1, 2, 2, 2, 2. And the reaction is balanced. So for your final reaction, you would say there's a coefficient of 2 on the KBr and a coefficient of 2 on the KOH. And that's a very simple equation to balance. So what about this one? This one's actually a little bit more challenging. Still relatively easy if you get the hang of it. Let's count it again. So we'll start with the left side. We have Al, which has just 1. We have O, which has 2. On the right side, we have Al, which has 2. And we have O, which has 3. So we're going to start with our easily multipliable relationships. We have 2 here. We have 1 and 2, and we have 2 and 3. 2 does not multiply easily into through the whole number, so we'll start with 1 and 2. If I put a 2 in front of the Al, that makes it a 2. It doesn't change anything else, and Al is good. The problem is there's nothing I can do with 2 and 3. Whenever you get into a situation where you're down to your last one and you're stuck, or if you want to attack it early, that's fine too if you can recognize it. But whenever you get down to your last one and you're stuck, find the one that's odd and double it. So in this case, we have 2 over here, 3 over here. This one is the odd one, so we're going to double it. Remember, we have to add a whole coefficient, so I'll put a 2 there. That's going to change the 2 in Al to a 4, and it's going to change the O to a 6 because 2 times 3 is 6. Al isn't good anymore, and O isn't good anymore, but I have 2 very easily multipliable relationships. If I want to go from 2 to 4 with Al, I just need another 2, so it's 2 times 2, which actually becomes a 4. So we'll erase that, and we'll put in a 4. And Al is 4, so that's good. And then O, which has a 2, has to get to 6, so I've got to multiply it by 3. And I'm left with 4, 3, and 2 as my coefficients on this problem. So if you do get stuck, find the odd one and double it. So here's one last one, and it's a little bit more challenging. So once again, let's count them up. We've got C on the left, which is 4, H, which is 10, O, which is 2. On the right, we've got to be a little more careful. We have C, that's 1. Then we have H, remember we go in the same order on both sides. This time H is 2. And then we have O. And we have 2 O's here and 1 O here, so we add them together to get to 3. So let's start by looking at our easily multipliable relationships. It is your choice, but I'm going to start with C. I'm going to put a 4 here, and when I put the 4 there, it's going to change that to a 4, and it's going to change my O to an 8 here, plus the 1 here, it's going to make my O a 9. The next step is I've got H. I've got 2 and 10, also an easily multipliable relationship. So I'm going to put a 5 here. That's going to change my H to a 10, and it's going to change my O to an 8 plus 5, or a 13. And now I'm stuck, because 2 to 13 is not a good relationship. So I've got to find whichever one is making the O odd on the right, but there's O in 2 places. If you notice, O is 8 here and 5 here, so it's this one that's making it odd. So what I'm going to do is double it, and I'm actually going to change this from a 5. I'm going to cross that out. Actually, I'm going to erase it. And I'm going to go ahead and make it a 10. When I make it a 10, what happens is it's still 8, but now this becomes 10, and this number is 18. It also, however, changes my h's from 10 to 20, because remember, you have to account for everything, which means I've got to go back and start working on my other relationships again. So first things first, I have 10 h's on my left, and I have 20 on my right. So the first thing I'm going to do is double the h's, which is going to make that 20, but then it's going to change c to an 8. That means I've got to double this side, 2 times 4, to make that 8. Let's put the 8 in. And that's also going to change O from 8 to 16, and 16 plus 10 is 26. Finally, with this being good and this being good, I've got 2, I've got 26. 2 times what gives me 26, and the answer is a very simple 13. So this one's a bit more challenging and a bit more complicated, but still doable if you just follow the rules I've taught you. So you can assume that any equation you get from now on is going to be unbalanced unless I tell you otherwise. You have to get good at this. Some of these are trickier than others. There are 2 worksheets. The first one you can get from the sub. I expect you to complete those 15 problems. Those are of the easy to medium variety, and turn that in so I can see that you know what you're doing. Once you've turned that in, if you want an additional bit of more practice, or if you want an actual challenge, there are some really difficult problems on the other worksheet that the sub has. I've put an answer key to that second worksheet in Schoology so you can check your work. But just know, a lot of these because I've been doing this for so long, I'm so good at, and I can do them in my head. Obviously, I don't expect that from you, but on the second worksheet, I actually do them on paper because they're so challenging. So I wish you good luck, but this is a skill you're going to need to practice. So take your time and get good at balancing these equations.